morning, everyone. Welcome to my presentation. This is Mahmuda Akter, PhD candidate, University of New South Wales, Canberra, Australia. My presentation title is Federated Learning-Based Privacy Protection Methods for Internet of Things System. In this presentation today, I'll go to these topics. These are Internet of Things, Edge Intelligence, Federated Learning, Differential Privacy, Data Distribution Methods, Privacy Attack Issues, and Work Evaluation, and finally, conclusion. Internet of Things. As we know that Internet of Things is an embedded network of interconnected physical things and peoples. There is several Internet of Things architectures in the research area. In the right of the table, we can see that the basic architecture has 3 layers. There's a device layer, network layer, and application layer. And there are also some references also has different several layers, like ITUT reference has 4 layers, WSO2 has 5 layers, FP7 reference has 6 layers, and Cisco, the latest reference IoT architecture, has 7 layers. In this picture, we can see the 7 layers, and the right one has 4 layers. In comparatively, we can see, and there in our research, we showed that there are several attacks might happen in these IoT architectures. These are PTCIA attacks. P elaborates privacy, trust, confidentiality, integrity, and availability. As we know that IoT devices generates data and it connects and exchanges through the network. There is so many applications of IoT in our practical area. There's a smart city, smart medical system, Industry 4, Agriculture 4. That's all are nowadays using the Internet of Things. Edge intelligence. Edge intelligence, or Edge AI, is a combination of AI and edge computing. It enables the deployment of machine learning algorithms to the edge devices where the data is generated. Usually, in the edge intelligence, the data is pre-processed and before uploading to the central aggregator. The central aggregator means the central server. And usually the edge intelligence stays in the near to the IoT devices where the data is gathered. And it is very great for multitasking, such as caching, managing offloading, and service delivery, and managing low response time, low communication cost, and higher privacy threats. The federated learning. Federated learning is a subfield of machine learning, which is focusing on settings in which multiple entities collaboratively train a model while ensuring that their data remains decentralized. In a one sentence, we can say that federated learning is a collaborative learning. That means where user and the server collaboratively learn each other. Where the data usually collect and model trains are managed in the IoT devices, and server will aggregate local models from the IoT devices and broadcast updated model to the all users. Nowadays, in defense, telecommunications, IoT, pharmaceuticals, all are using the federated learning. Differential privacy. Differential privacy is a mathematical framework for ensuring the privacy of individuals in datasets. It can provide a strong guarantee of privacy by allowing data to be analyzed without revealing sensitive information about any individuals in the dataset. The differential privacy model has 2 types. One is a local differential privacy, another is a global differential privacy. In the local differential privacy, aggregator cannot access real data. But the global differential privacy, the central aggregator can access all the data. In the local differential privacy, each user apply differential private mechanism to their own data, and they anonymize the data and send to the aggregator. Whereas the global differential privacy mechanism applied once, and it has a higher accuracy. There's a 4 type of noise adding mechanism in differential privacy. One is exponential, another is Laplacian, third one is Gaussian, and fourth one is hybrid. In our work, we use the Gaussian mechanism for complies with epsilon and delta differential privacy rather than pure epsilon differential privacy. In our research, we use 2 types of data distribution methods. One is IID and another one is non-IID. IID elaborates independent and identically distributed, where the data is handled and shuffled in a random order, so that 2 clients can get similar class level data. And in other side, non-IID is not independent and identically distributed. The data is needed to sort first, then distribute to all clients, and clients will not get similar class level data. This is the overview of the attack issue in PTCIA, in IT-related security and privacy. In this figure, we can see that in the federated learning, they're showing the 3 layers, 3 IT layers. The bottom one is device layer or perception layer. Middle one is network layer, and the top one, where is the server is, there is application layer. And there's categorized as 2 privacy threats. One is passive threats and another is active. For the trust, mainly requires in the IT layer in application layer. And trust is selfish, maybe honest but curious behavior. That is trust issue. The integrated issue is tampering. Delay processing availability is jamming. Privacy is authenticity. Authentication, vulnerability is a privacy attack. Confidentiality attack might happen. That interference, spoofing, eavesdropping, that type of attack might happen in this different layer. This is the work evaluation of our work. Usually we hyper tune the federated learning, and we show that in which iteration and which learning rate and best size and which data distribution our higher accuracy will be gained. In this figure, we can see that the green line was that iteration is 150 and learning rate is 0.1, and the best size 128 and client is 10. And in IID distribution, we can get the higher accuracy, almost 90, more than 90%. In conclusion, comparative referenced IoT architecture with the categorized PTCI privacy attack paradigm were briefly discussed in this paper. An overall summary of federated learning and its categories were presented, and the potential privacy threat of federated learning from an IoT perspective was investigated also in this paper. And finally, we shows that several recent research challenges and their causes were described and recommendations for solving them in this paper. Thank you so much for your attention. Any question?
Thank you very much for your presentation, Ms. Mahmuda Akter. And are there any questions from forum? Is there any question? There is no question from the venue. Are there any questions from forum? I think there is no question from the forum. If you don't mind, may I know the future research direction of your work, please?
Yeah, sure. My future research of data is the implementation of edge intelligence in real scenario, and I'm also working on that. and how can we enhance the privacy without sending directly to the global aggregator, and it will remains on the user's devices. The data will not leave the user's devices, so that we can avoid some of the privacy attack which is happening during the network communication channel. We are working on that. This is our future work, and hopefully sooner we will get the promising result. Thank you.